In today's lesson, we are going to see an introduction to the solid principles. The solid principles are a collection of principles that help the developers to create clean and scalable code, and are a collection of principles that are frequently asked in the job applications. So in order for you to be prepared for that job application, you need at least to know what they mean and how they can be applied. First of all, you need to download the code of the project. I have done some changes in order to be able to do this lesson. So the solid principles are a methodology that we can apply to our code to make it cleaner and scalable. These principles are composed by the first one, single responsibility principle. There should never be more than one reason for a class to change. In other words, every class should have only one responsibility. The second principle, the open-close principle. The software entities should be open for extension but closed for modification. The third principle, the least code substitution principle. Functions that use pointers or reference to base classes must be able to use objects of derived classes without knowing it. The fourth principle, the interface segregation principle. Many client-specific interfaces are better than one general purpose interface. And the fifth and last one, the dependency inversion principle. Depend upon abstractions, not concretions. As we have done so far, we are going to try to learn all these concepts by doing examples. So let's start with the first one, the single responsibility principle. And the first principle that we are going to see is the single responsibility principle. That defines like this. The single responsibility principle is a computer programming principle that states that every module, class, or function in a computer program should have responsibility over a single part of that program functionality, and it should encapsulate that part. So our goal when applying this principle is that our different components only manage one functionality, improving that way their independence and modularity. So we are going to do two examples where we will start with a situation where a component is managing two different functionalities, and our job will be to create the necessary elements in order to separate that functionalities to meet the solid principles. Okay, the first example will be that the player has responsibility over the items, and the second example will be that the player has responsibility over the inputs. We want to apply the solid principle to both situations in order for managing the items in their item manager controller and also the inputs in their own input controller. The first example that we are going to do is that the player is going to have a responsibility over the items, and we don't want that. We want that the items are managed by its own item controller. So what we are going to do is that we are going to create two types of items. One type to increase the ammunition, and another type to increase the life. In order to do that, first of all, look in the Unity Asset Store for two types of items in order to increase both the bullets and the life. So go to the Unity Asset Store, look for free assets, Once you have downloaded a couple of assets in order to implement these two types of items, to increase the ammunition and to increase the life, you are going to start coding to implement the whole thing. What will happen is that on the player script, you are going to detect when the player collides with any of these two items, and when it collides, it will increase its ammunition or its life. Next, you are going to do exactly the same for the case of the enemy. If the enemy collides with the item, he will also collect the item. So go ahead and do it. and the result should look similar to this. What we have done, we have started by creating the script item. We have defined an enum type with the type of items we will have in the game: coin, ammunition, and food. Since we are going to manage the coin with the item, we have deleted the script coin in order to be able to manage it with this new script item. After deleting the script coin, we had to fix in the level controller anything related with the coin. Now we are considering that the item type should be coin in order to add into a list of coins. The same when deleting the whole thing. When a coin has been collected, we just check by item. The next thing that we've done is both in the player script and in the enemy script, we are just checking if we collide with the item. If we collide with the item, we check the item type, and if it's a coin item, we proceed as before. We add the coin and report the coin has been collected. If it's of type ammunition, we increase the ammunition and we refresh in our UI the total amount that we have available of ammunition. Finally, for the item food, we just increase the life. And we are doing exactly the same for the enemy. Okay, the enemy can collect also, can collect coins. Right now the ammunition doesn't do anything, it just collects it and destroys the item. But the item food, it increases the enemy's life. If everything has worked fine, if we proceed, let's decrease the life of the player so we can collect food and increase the life again. Okay, 1 hit, 2 hits, enough. Okay, so now, as you can see, the ammunition is 10 units, but if we collect the item ammunition, it's increasing 5 units, and if we collect the hamburger, the item life, we increase another 20 units. Increase ammunition, increase life. Okay, so the system is working. So right now you understand that you are repeating the same code in both classes, in the player script and in the enemy script. So both classes are managing the behavior of the items aside from its own behavior. So we are not meeting the solid principle of single responsibility. So now what we are going to do, we have to isolate the functionality on our item controller singleton. So go ahead and do it. So the code should look similar to this. First of all, we have created our item controller. Okay, then we have created a new empty game object on the scene, and we have added the component item controller to it. The next thing that we have done is on the start method, we are listening to the system event controller, and we have declared a public method register current level items. And this method would do is just to find all the items in the level and keep them here. We have declared a destroy method because every time we transition of level, we need to clear the previous existing items. And on the listener for the events, we are listening for this particular event that we have created for this occasion, the event item collected. And this event is being dispatched by the item. Okay, when the item collides with something and that something is an avatar, then it dispatches the event and the item controller listens for that particular event and deals with it. Okay, it gets the item, the avatar who has collected the item, it evaluates the type, and depending the type, if it's for the player, it adds a coin for the player and dispatch that even coin collected. And for the ammunition and for the food, just access to the methods increase ammo and increase life in order to increase the values of that particular properties for the avatar who has collected them. Finally, we destroy the item. And on the player, we have removed all the logic related to the collection of items and also in the enemy. The enemy no longer have to deal with also the collection of items because we have moved all the logic to the item controller. And in this way, the single responsibility principle. So everything related to items is going to be handled by the item controller. So if we did it right and we proceed to run, we should get exactly the same behavior as before, but this time with a code that is cleaner, and we will be able to grow it in a better way. Enough. And let's check how the life and the bullets are increased. 12 bullets, 17 bullets, 60 of life, 80 of life, and more life and more bullets. Okay, so it's working. The second example of application of the single responsibility principle will be about isolating the inputs in its own manager. Right now, the player has responsibility over the inputs. So what we are going to do now, we are going to put more responsibility over the inputs in the player script, just for you to notice that it doesn't make sense that we handle the inputs in the player. So you can see more clearly why we are going to move out this input management from the player to its own input controller. So what we are going to do is that aside from controlling the keyboard, we are going to check if the user presses the gamepad buttons. And we are going to control three actions. We are going to check for the shoot. Aside from the mouse click, we are going also to check if the button of the gamepad fire 1 has been triggered. For the jump, aside from the spacebar, you are going to check also if the fire 2 has been pressed, and for the camera switch, you are going to check the button fire 3. So go ahead and do it. and the result should look similar to this. In the player script, aside from getting the input of the space, we are also getting the input of the button fire to. We check if any of these two inputs is active in order to trigger the jump. We do something similar for shoot bullet. We get the input for both the mouse button down and the fire one, and if any of these two are triggered, we proceed to shoot. And finally, for the case of the camera controller, if any of the two inputs, if the user has pressed on the key Y, or if he has pressed on the fire 3, we proceed to switch the camera. Now imagine that you are asked to make a mobile port of the game, so it has to work with a touch screen. You can start to see the problem. You have also to add the touch functionality inside the player script and also inside the camera controller script. Now imagine that we go further and we have to deal also with virtual reality, augmented reality, or anything else. So what we need to do in this case to meet the single responsibility principle is that we need to isolate the behavior of the input in its own class, input controller. So we could ask about all the previous actions without bothering where they come from. So the input controller will deal with all the inputs related with the movement, the shoot, the jump, and the camera switch. So go ahead and do it. And the code looks similar to this. First of all, we have created our Singleton input controller, and we have created the methods to deal with the input, to check the input. For example, for our case, in the case to detect that the jump button has been pressed, we have created this method that checks both the space bar or the fire to button, something similar for checking if the button to shoot has been pressed. We check the mouse button down and the fire 1 button, and also something similar for the camera switch, checking the Y E and fire 3 button. By this way, we have encapsulated all the functionality related with the inputs inside this class. So both player and camera controller don't need to know where it comes the signal, the input, because both player and camera controller will only receive just the signal that it has been pressed, but they don't need to know from what input. So this way you can isolate the behavior and just deal with multiple types of inputs that can appear in the future. The next principle that we are going to do is going to be the open-close principle. So the official definition of the open-close principle is software entities, classes, modules, functions should be open for extension but closed for modification. The goal of this principle is to create modular elements that, when used in any project, don't need any kind of modification in order to use them. Any specific functionality a new project may need from that module will be done as an extension. That means that we are adding additional functionality to the module to use it in our particular project without the need of modifying the existing module. We have two options in relationship with extending the functionality of a module. We have the concept of inheritance. The inheritance allows the programmer to create classes that are built upon existing classes to specify a new implementation while maintaining the same behavior. We have been doing all this all the time since we introduced the concept of class inheritance. And the other way to extend the functionality would be the composition. Object composition and object aggregation are closely related ways to combine objects or data types into more complex ones. So right now in our project we have our camera controller that handles two cameras, the first person camera and the third person camera. Let's consider that camera controller could be used in multiple projects, so we have to avoid as much as possible to modify that class. Now for our project we need to implement a new camera state called camera free, where we will be able to move independently the camera from the player. So our goal is to create a custom class called camera controller free that will inherit from camera controller and will extend its functionality to be able to manage this new state where we will be able to move freely. So go ahead and do it. And the result should look similar to this. What we have done is, first of all, just to create a new script called camera controller free. And in this new script, we are inheriting from camera controller. Okay. And what we are doing with camera controller free, we are extending the behavior of camera controller. And what we are doing in camera controller free is just considering that we can transition to the camera free state. Okay. And the camera free state, we will perform both the movements and the rotations to move the camera independently from the player. And related to the camera controller, the only thing that mentions to the camera free is just this state in the enum-type camera states. Aside from that, other changes that we have had to do is to virtualize some methods in order to be able to extend them. For example, the method switch camera state, we have had to virtualize it in order to extend it to consider switching to the camera free state. And in the update method, we have also had to virtualize it in order to extend it. So what we are doing here is just considering the camera free state, and after that we are running the inherited behavior related to the previous cameras. So if everything is right, we should be able to switch to the camera free, and we should have the behavior related with the camera free. And we can switch back to the whole thing. So that has been an example of the application of the open-close principle. Instead of fully modifying the element camera controller to add the new behavior of camera free, we have extended that class in order to prevent any modification to that class. This would make much more sense when you create your own libraries of utilities that will be shared between multiple projects. And we will see an introduction to the creation of that libraries in the lesson related to the namespaces. The next principle that we are going to see is going to be the Lisco substitution principle. The official definition reads like this: based on the concept of substitutability, a principle in object-oriented programming stating that an object, such as a class, and a sub-object, such as a class that extends the first class, must be interchangeable without breaking the program. Okay, so the goal of this principle is to work with elements with common properties without needing to know what types of sub-elements are instance of. Okay, let's try to focus in here and just keep in mind the word substitutability. Okay, that means that you can replace one thing by a derivated class and everything keeps working. Okay, let's try to do examples so we can try to understand what this means. For example, this is we are not going to program this example. This example is just a mental exercise that you are going to do right now. In the part of the lever controller script, we would have just a method called bomb explosion damage that will receive three parameters: the position of the explosion, the range of the explosion, and the damage of the explosion. And it will go through all the enemies. Okay, if the enemy is in the range of the explosion, then it will decrease the life, and it will apply an impulse, a force, in relationship with the position of the explosion. And in the enemy script, we would have this public method apply impulse that will receive the vector of the force that where we need to apply the force. Now think about replacing in the level controller, instead of having this line right here, to make reference to the avatar instead to the enemy. Okay, if we do the change of replacing this by avatar, this is going to work? Yes? No? Can you think about the reason why it's not going to work? Okay, so it's not going to work because apply impulse belongs to the enemy script. It doesn't belong to the avatar. We would have to move this apply impulse from the enemy up to the avatar in order for to be able to apply all the bomb explosion damage to all the units independently if they are enemies, NPCs, or the player. Okay, so here we are not meeting the principle of least cost substitution because we cannot switch from these two classes. In order to be able to do it, we would have to move the method from the enemy to the avatar. So let's make another example to evaluate the potential of meeting this code design principle. And now what we want to do is in our commander controller, we should be able to select anything. Aside from the enemy, we should be able to select the NPC or the player. And we also want to set as a target also anything. Again, the enemy, the NPC, or the player. As an advice of how to start, just replace that instead of only selecting enemies in both for target and the selected units, let's select avatar. So do that change and fix the errors in order for the system to work. So go ahead and do it. And the result should look similar to this. The first thing that we have done in the command controller, we have replaced the reference of the enemy to the avatar, and we have fixed all the instances where we were using both list and target reference by avatar. And aside from that, for the NPC, we have added the wait instructions, the state that is going to be the NPC in the case that he's ready to receive instructions, and we have done something similar of what we did for the enemy, in the sense that once it enters this state, it never leaves until it dies. Also, in the level, we made sure that the NPCs are on the right layer, that is the layer NPC. So in the command controller, when we are raycasting, we can select them. If everything is right and you run the project, you should be able to select the three elements, the enemy, the NPC, and the player. So go ahead. Let's go with the NPC. And select a position to move. Okay. Next one, the enemy. Another position to move. And the player can also move right here. And we can also select all of them. Okay. Let's get a better angle. Select all of them and move them to a target position. Okay. So we have replaced it from enemy to avatar, and we should be able to replace back without too much problems. In that sense, the command controller can manage the whole system independently if the managed units are enemies or the class from which it inherits, that is, avatar. The next principle that we are going to see is the interface segregation principle, and the official definition reads like that. The interface segregation principle, ISP, states that no code should be forced to depend on methods that it does not use. This principle splits interfaces that are very large into smaller and more specific ones so that clients will only have to know about the methods that are interested to them. Such shrunken interfaces are also called role interfaces. ISP is intended to keep a system decoupled and thus easier to refactor, change, and redeploy. In short, we only define interfaces only with the functionalities we need to offer. That improves the cohesion and modularity. So let's do an example to try to understand this principle. And what we are going to do is just to create an interface in order for the items controller component apply the effects of an item on a unit that inherits from avatar. In the current state of the project, we are using the avatar class as the interface to apply the changes. So right now, all the public methods and variables that avatar is offering are available to the items controller. So right now, we are not, the principle of interface segregation is not being met because we don't need to have access to all the public methods and variables. So what we are going to do is to create an interface that will be applied to the elements player, NPC, and enemy that only implements what is necessary for the item controller to work. So go ahead and do it. And the result should look similar to this. First of all, we have created some more folders in order to better organize the whole project. We have created these folders, okay? And for the folder items, we have created the new script item effect. That item effect is the interface that we have implemented in order for the item controller to only know about what it needs to perform its function. Okay, so for this interface, we have created the methods increase life and increase ammo. And what we have done is to apply this interface to all the elements that are going to need it. In the case of player, in the case of NPC, and in the case of enemy. And what we are doing now is that item, when it collides with something, it checks if it has that interface. If it has that interface, okay, it reports to the item controller. And the item controller just gets only the information it needs to perform the operation. And the only things that it needs are these two methods, the increase ammo and the increase life. So finally, if we run the project, we should get exactly the same behavior as before. But now we are meeting the interface segregation principle for the management of the items. The advantages about the application of this principle is that we reduce to the essential the possible number of dependencies between elements, allowing this way to create a more modular and cohesive code. When you are starting to learn about development, you may be inclined to make everything available, but as a professional, you need to consider techniques that will help you out to create stable projects that could grow without major issues. The last principle that we are going to see would be the dependency inversion principle. The official definition reads like this. The dependency inversion principle states that a high-level class must not depend upon a lower-level class. They must both depend upon abstractions. And secondly, an abstraction must not depend upon details, but the details must depend upon abstractions. In plain words, in order to improve the modularity and reduce the dependencies, we are interested that a class don't depend on an instance of a class, when the other class could potentially be changed by other classes. Let's do an example. In the GameController, we have a direct reference to the player class. So let's suppose that we want to create a game where we control totally different types of players. For example, we are going to define a tank player, flying player, and human player that inherit from player. So we assume that we can switch between these three different players at any time. Now we can see that our direct reference to the player could not work, because we may have substantially different properties for each subclass. So we are not meeting the principle, because GameController depends on the player script. So we need abstraction. In order to meet the principle, what we will do is just to create a new interface iPlayer, and we would implement the necessary methods that we need to offer for the system to keep working. Okay, so the interface I have detected that only needs the GameController to work would be this one. So in the moment we need to create the tank player, the flying player, the human player, we only need to implement that interface, and that would be the interface that the GameController is going to manage. So what we have done here is just to create the necessary abstraction to meet the principle. So now what you are going to do is to implement this interface and replace the reference in the controller. So instead of pointing to the player, that points to the interface. Take into consideration that the interface that you see on the slide is incomplete. So when you are implementing the whole thing, you will notice that there are some methods missing to include in this interface. So you will have to implement it. So go ahead and do it. And the solution should look similar to this. What we have done, first of all, create new folders for better organization. We have created these folder instances where we will place anything that inherits from avatar that can be instantiated in the game. And here in these folder interfaces, we have created the interface iPlayer. As I told you, the interface, the final interface for iPlayer is larger than the one of the slide. And what we have first done is just to implement the interface, replace it in the game controller. Instead of having the reference to that the player, we have now the reference to the interface. And once we have replaced that reference, all the compiler errors have appeared, and we have gone through fixing all of them. And when we needed to implement another method for the interface, we did it. We created new methods in order to be able to work with the interface instead directly with the player. And once we fix all the compiler errors and all the references that were missing, then on the start method, what we are doing is that the same player is reporting when it has been initialized and the game controller is listening for that. Okay, so when the game controller listens for this particular event, then it will set the reference to my player. Once we have set the reference, we should be good to go, and we should get just exactly the same behavior as before. Okay, so if we run the project, we can shoot, we can jump, we can change the camera, we can do just exactly the same that we were doing before. But this time, meeting the principle of having a more cohesive and clean code. So let's do another example. The player script has a dependency in relationship with the game HUD. Just imagine that there might be different HUDs. Let's suppose that we are implementing the previous example that we have talked about, and we would have different types of HUDs. A HUD for the player, a HUD for the tank, and a HUD for the flying player. Okay? So what you are going to do is to create a new script called HUD that will manage just the current HUD. And you are going to implement an interface, iHUD, that will offer the necessary methods to the player. Okay? The script HUD will implement that interface, and the player will make reference to that interface. Okay? And with this structure, we would be able to implement in the future different types of HUDs. Okay? So go ahead and do it. And the code should look similar to this. What we have first done has been to create the new script hat, and we have moved all the text fields from player to the hat. Okay, and we have created public methods to set the value of all these text fields. Okay, next we have created the hat with all the methods that we need from it. And then in the scene for the game hat, we have added the component to it. And we have set all the text fields in their references. The next thing that we have done in player, now we declare a private member variable pointing to the interface, and we are listening for the hat to be initialized, okay? And when the hat dispatches this event telling the system, okay, I have started, we set the value on the player and we first update the values on the text fields. Next, we have just fixed all the compiler errors related to the old code, and we have just used the interface and the methods in order to display the information in that interface. So in short, we should have the same behavior as before. We should get the ammunition in order, the life also gets decreased, and the message of danger enemy and NPC are working fine. So with the interface in place, the hat can be replaced by another one and the player won't notice anything because he would be only using the methods provided by the interface. So as long as new hats implemented the interface, everything should keep working fine. So let's keep working in the hat, because what we are going to do is we are going to create a new interface that we will call iCommander hat. And this interface is going also to be implemented by our script hat. The script hat will also have the interface, and this interface is going to define the functions that are going to be used by the commander controller to display the information. Okay, so go ahead and do it. And the result should look similar to this. What we have first done has been just to create an empty game HUD, okay, just the interface, and then we have added the interface to the HUD, okay, but the interface wasn't going to be empty, so what we have done is just to move all the references to the text fields that were on the command controller. We have moved it from the command controller to the HUD, okay? And we have defined a collection of methods in order to initialize all of them. Once we have defined all the methods, we have gone to the interface and defined the methods that we want to offer. Then back to the command controller, we have created a private member variable, a reference to that interface, and when we listen the event that the HUD has been initialized, we get the reference to that interface, we initialize the interface, and we can start just accessing that interface in order to display all necessary information for the command controller to work. The result should look just like always. It should be working. So we go into commander modes and we can select the units, the player, the NPC, the enemy. So we have successfully created a new interface that reduces the dependencies of the command controller to what is strictly necessary to perform its function. And with that, we conclude the lesson related to the solid principles. As an additional exercise, I propose you to go further and try to identify in this project and your own project parts of the system where you could apply this collection of principles to make a more clean, modular, and cohesive code.